Okay, so from this example right here is going to sound kind of generic. She's walking blocks from her dorm. But I want to tell you how this kind of relates to like my actual real life. So I live on a farm out in what's called Gaines. I don't know if anyone's even heard of it. It's now out near Sports Creek. And we call where we live kind of like our little Condell compound because Phil's family, my husband's family, all live out there. It's really kind of weird and creepy. But here's this is like what it's Baldwin Road. This is Nichols Road. These are pretty well-traveled, busy roads. My in-laws live right here. And this is where the farm is. We live on a farm. I guess I don't live on a farm. My in-laws live on the farm. Ladies, pick good in-laws because I'm about to show you how close I live to mine. I live right here. I live really close to my in-laws. We call it the compound because here's my husband's family, like my husband's parents. Here's his uncle and here's his aunt. Anyone else live that close to all your family? Like that? It's kind of crazy, right? So what's behind all of us is farmland, which is nice because it's nice and quiet and it's pretty this time of year with the colors changing. But what's annoying is that if I want to get, say like my kids are on my last nerve and I want to send them to my in-laws, I got to have them walk this busy road and then this busy road. Or wouldn't it be nice if my father-in-law just like paved through his farmland a shortcut? We always joke around with him that we're going to do it. And we never do because this is their source of income. But this example that we're about to walk through is pretty much like my real life. Like you've got someone who has to walk this way and this way, but it'd be a heck of a lot easier if we could just do a quick shortcut through. We always joke that we're just going to take a lawnmower and go through his farmland so that I can just shove the kids through the farmland. Because these roads are super, super busy, and there's no way I would ever allow my kids to just walk over there at 6 years old. But I would do this way, happily. I bet I could see them do the whole way. So, thinking about this in my crazy life out on the farm, we're going to talk about Donna. Because Donna's kind of dealing with my same situation, but she's at college. So Donna walks home to her dorm from class one day, probably every day. She has to walk 6 blocks north and then 7 blocks east. So she walks 6 blocks north and 7 blocks east. Like that's like me going 6 blocks north, 7 blocks east. How much shorter would her walk be if there was a direct path from her class to her dorm room? So she's trying to figure out how much faster it'd be if the school would just probably like bulldoze down some buildings so she could just quickly get over there. It's kind of like me wanting to take my lawnmower through my father-in-law's crops. I can only imagine what he would do to me. So right now, if Donna's walking 6 blocks north and 7 blocks east, Donna's walking how many total blocks? Right now. She's walking 6 blocks north and 7 blocks east. How many blocks is she actually walking? 13. 6 plus 7 is 13. So right now, Donna is walking 13 blocks. So what we need to figure out is really how many blocks or how long would it be if there was a direct route. So we're going to draw this out using a coordinate plane. And then we're going to calculate a distance, and then we'll be able to figure out how much shorter would it be. So since they use north and east here, we're going to use, on our coordinate plane, it's the easiest way to do north, south, east, and west. Okay, so on a coordinate plane, this would be, the top's always north. And do you know the never eat soggy waffles? No? For north, south? Okay. Never, and then go in clockwise order, never eat soggy waffles. North, south, east, west. So let's figure out where Donna's going here. So she starts off at her class. So this is where her class is at 0, 0. It's the easiest way to start at 0, 0. And from class, she's going to walk to her dorm. She goes 6 blocks north. 1, 2, 3, 4, 5, 6. Then she turns and goes 1, 2, 3, 4, 5, 6, 7. blocks east. And then she ends up at her dorm. Like this is literally this is my actual situation here. You go north and then east. They want to know how much shorter would it be if Donna could just go straight from class to the dorm without having to go up and over? What if we could just go straight there? Donna's feeling the condyle pain as well. So what we have to do in order to figure out how much shorter her walk would be, we need to figure out how long this walk would be. And what we just created is a segment so we can find the distance between this point and this point in terms of a segment using the distance formula. So in order to use the distance formula, though, you have to have coordinates. So that's why we put this on a coordinate plane, because in order to use the distance formula, you got to have the coordinates. Class, this point right here at class, what's the coordinate for class? 0, 0. So 0, 0. And then here's the tricky one. What would the coordinate be for the dorm?
7, 6.
Oh, you didn't fall victim to it. Good job. It'd be 7, 6. So if this is 0, 0 and this is 7, 6, and we have to plug into the distance formula, I'm going to label my points. I'm going to label my dorm X1, Y1, and I'm going to label my class X2, Y2. Mainly because I know that when I plug this in, I'm going to be subtracting, and I want to keep numbers positive. And it doesn't matter which one you label as X1, Y1 or X2, Y2, as long as you stay, like, these have to all be the ones, these have to all be the twos. So then I'm going to plug into that distance formula, square root, parenthesis, x1 minus x2, 7 minus 0 squared, plus parenthesis, y1 minus y2, 6 minus 0 squared. So plug into the distance formula. Now I'm going to use order of operations, take care of what's in those parentheses first. 7 minus 0 is 7 squared, plus 6 minus 0 is 6 squared. And again, I'll probably say it every time we square something. When you square something, you multiply it by itself. 7 times 7 is 49, plus 6 times 6 is 36. 49 plus 36 is 85. Now I can take the square root of 85. So 85 square root gives me about 9.2. So to get from class to the dorm, it's going to be about 9.2 blocks. It's not going to be full blocks because remember, we're not really walking blocks here. So right now, Donna's walking 13 blocks. But if there was a shortcut, it would only be 9.2 blocks. I'm going to go back to the directions and read to see what they actually want. And then what they want is how much shorter would her walk be if there was a direct path? So do they want the 9.2? No. So how do we figure out how much shorter it would be? Subtract them. Take the 13 blocks that she's writing right now. Subtract the 9.2 that it would be if they built that nice walkway. And how much shorter would it be? 3.8 blocks shorter. I should tell my father-in-law. It'd be a heck of a lot faster for us to get over here. That's probably why he doesn't do it. He doesn't want us to come over there. I know it now. Busted. Any questions on that? Okay, what you're doing today. You are going to do number 5 on this page, which is very similar to the one that we just got done talking about, except we have Stephen going on here. Stephen instead of Donna. And then you're also on page 10. You're only going to do number 3, which sounds like not a lot, but number 3 is very deceiving because for number 3, you have to find the distance and the midpoint between Donna and Stephanie, the distance and the midpoint between Stephanie and Stephen, and the distance and the midpoint between Donna and Stephen. All of these points are right here that you're going to use. Actually, I don't think you need Vincent at all. Vincent is worthless to us today. You just need Donna, Stephanie, and Steven. So these ones right here, just again, getting you comfortable with the formula. I know some of you probably all feel good about that. The good news is that the distances, you should get good solid numbers, no decimals. Midpoint, I think you get a couple of decimals, but they're not really gross decimals. And then here is number 5 is very similar to what we just got done doing. So you're doing pages 10 and 11, number 3 and 5. If someone saw that, they'd probably be like, that's it?